Yes, good morning. Welcome to the case study discussion on fan blade fatigue failure on the CFM 56 engine. This is the airline Flight 138 engine failure. So here we are going to discuss about the fatigue failure, especially metal fatigue failure, crack initiation, and failure identification using NDT method. So we are going to start the discussion.
The Southwest Airlines Flight 13680 incident occurred in April 2018 involving a Boeing 737 aircraft powered by a CFM 56 engine. During the cruise, one of the fan blades fractured due to fatigue. This failure caused high energy release to impact the engine sink. Unfortunately, parts of the debris escaped the engine, damaging the fuselage and leading to a cabin depressurization. This makes it significant case of uncontained engine failure. One of the key concerns with this case is why the crack was not detected during the inspection. Fatigue cracks often initiate internally or a location that are difficult to assess. Traditional inspection methods may not detect very small or subsurface cracks. So when it is not detected, these cracks will grow over time during various flights, so it will get worse.
From this observation, the flight failed due to fatigue blows. So this was not predicted in the earlier inspection. Unfortunately, it got damaged the entire engine. Because if engine gets failure, it directly affects the carbonization pressure. This is what the observation in this case is. So let's go on further discussion.
Metal fatigue is a phenomenon where the materials fail due to repeated cyclic load, even when the stress levels are below the ultimate strength of the material. In aircraft engine, components like turbine fan blades undergo continuous rotation, experiencing cyclic load every flight. Over time, these repeated cycles weaken the blades and eventually leading into failure. And the failure in this case is categorized under high cycle failure. This type of failure occurs when a component experiences very large number of cycles at a relatively low stress level. Fan blades in the jet engines rotate at high speed, accumulating millions of cycles over their stress life. Even a small fluctuation can lead to failure damage over time. High cycle fatigue is particularly dangerous because it progresses slowly but results in sudden and unexpected failure.
This is our observation. We are focusing on high cycle fatigue. We have two cycles of fatigue. One is low cycle fatigue and high cycle fatigue. High cycle fatigue classes when the argument strength is below the yield distress. Before attending the yield distress, it will get classes the failure. So it is unpredictable and it will operate the infinite life cycle, that median life cycle, but the failure will occur without modifying anything. So that is what this has happened. Especially we have several blades in the engine like turbofan, inducer fan, and compressor blades and turbine blades. So this failure occurs in the turbofan section. If the blade gets failure, it will affect the entire engine, which causes the major damage. So that is what the observation in the discussion. We move further.
To detect these flaws, we will be using NDT method, so non-destructive testing method. It is, plays a crucial role in that, like detecting the fatigue without damaging the material. So normally we are using ultrasonic testing for the internal crack damages, and also the eddy current testing is for the surface damages. But for the advanced technique here, we will be using thermographic and acoustic emission testing. This is for the improvement of the detection capabilities. So further, like the effectiveness of the NDT depends upon the crack size, orientation, and also the equipment sensitivity.
So this is one of the real case where we have failure, and moving to the maintenance part and identifying the failure using NDT. That is not destructive methods. And using ultrasound testing, so we can predict the failure before it happening. So nowadays they are moving to different technologies like digital twinning and virtual methods and using sensors and what is that? Sensors and one more
So acoustic
emission and
thermography.
These are image sensing methods where we can predict the cracks and crack growth. So which is helping us to finding predicting the life of the planes.
Typically begin with the crack initiation, then this crack often originated stress of concentration points at the surface inclusion or microstructural irregularities. Initially, this crack are microscopic and cannot be easily detected. As the component continues to operate, the crack will gradually propagate under the cyclic load. Once the crack reaches size, the remaining cross section cannot support the load, leading to sudden fracture, as seen in the engineering failure.
So the aircraft engines are designed with containment systems to keep the broken blade pieces inside the engine gas. But in this case study, the engine power is too high, so it's exceeded the containment limits. So because of these debris, it exits from the engine gas and hits the aircraft fuselage. So because of this, it's a very difficult to affect the passenger safety and the aircraft structures.
In this case, we have told that the weight is not only affected the engine as well as it is affecting the fuselage. So while designing such component, and fatigue is a major thing we have to consider. As an engineer, as a maintenance thing, we have to consider the periodic inspection using all the technical like LVT, ultrasonic or the thermographic method. The inspection should be done in proper manner, as well as the material which are used for the blades or the structure, which has its own lifetime, like ice cycle or road cycle. Thing we have the predictive life cycle. So using advanced technology, predictive analysis, we can able to find or we can save the metal failure before getting into creating a lot of problems. So this case will help us to understand how fatigue is happening, how high cycle fatigue is happening, and what are the inspection method help us to finding the crack propagation or crack development, and what are the other cases like if you are not only affecting the engine, it will also affecting the other part of aircraft. Right? Thank you all.
Thank you, sir.